Hey everyone, Sam here. I'm back, and I am now going to work on the upper middle shelf right here that I hinted at the end of the last video. So you can see I've got a lot of stuff in this drawer, so I'm just going to go through it and introduce all these elements to you guys. So, let's get started. First element, scandium. It's a rather rare and expensive element, but I am lucky to have a sample here. It's a couple of really nice crystals. Yeah, I'm actually going to go put some mineral oil in here. I mean, not sure if it's like gonna tarnish or anything, but you know, just in case, I'm just gonna put a little bit in here. I've kind of learned that you don't really need to fill the whole thing with mineral oil. You just have to put enough in to cover all the particles with a coating of oil, and that will help stop the oxidation. Shake it a bit, roll it around in there to get it all covered. Let's see. Yeah, I think that's sufficient. Alright, scandium. Move this oil aside. Okay, moving on, I've got titanium. Really nice pellet in here. It's been arc melted, but you can see titanium has kind of this nice yellow color to it. I've heard that that color actually isn't from the metal. It's actually because of the protective oxide layer on the metal, which is really interesting. I did not know that. But, there we go, titanium. Pretty simple one. Moving on, here I have got vanadium. Some really nice crystals in here. Beauty. You can actually see, if you look closely, there's some iridescent tarnish on them. Very aesthetically attractive. I like that. Yeah, okay. Let's see. Yeah. Right, next one, chromium. Some really nice shiny pieces in here. They're kind of big though, I might need to break them up a little bit. So, yeah, I'll actually go ahead and do that. Okay, so here I got the chromium. Here's the chromium, by the way, that was left over in the bag. I couldn't fit it in the vial, so I'm actually going to break this up first of all. Actually see how brittle it is. It is quite brittle, actually, yeah. Nice. Oh, wow. Cool. Okay.
Yeah.
As for this, bits of chromium are stuck in the mouth, so these are gonna have to come out.
I hope that this isn't as hard as silicon.
Seems to be a bit less hard than silicon. I mean, it's still a pretty hard metal, but its mechanical properties are more workable than silicon, it looks like.
Yeah, at least this time, the people, at least these aren't, like, where you have huge fits.
I know.
You know?
Yeah. Yeah, silicon is a nightmare.
Yeah.
Okay. Alright, yeah, put a bit more mineral oil in, because... Okay, Alright, I got the chromium out. That was a lot of oil, as evidenced by the big splash here. So, let me just crack these apart. Does seem to be throwing a few chunks here and there, but it's not as bad as the silicon, where I got a mess of silicon all over the table I had to clean up. Oh, nice. Oh, yes. Okay.
One big mess.
Okay, chromium was much easier to break than silicon, needless to say, but I still did get a lot of little bits of it everywhere, so I'm just eating up all this oil for one. Now, some of you might be worried about the environment, and now it's true that like chromium in the environment is a problem, but this isn't the toxic form. This is the metallic form. The trivalent and metallic are not very harmful. In fact, the trivalent, I think, is an essential nutrient, but in trace quantities. But it's the hexavalent that you need to worry about. That's a toxic kind of chromium. But this is metallic. So. All right, I got the chromium in the vial here. Very nice for display. There's some residual oil in there, but that's no big deal. By the way, some of you might be thinking I'm kind of using oil obsessively for this project, and yeah, I have been using a lot. In fact, I've used about half of it so far. Might need to get more soon, but you know, it just helps to lubricate the samples when they're stuck in the vials, and also in cases with reactive metals and other such materials. It just helps to prevent oxidation, or greatly slow it down, at least. But I might need to get more soon, because I've already used about half. But anyway, this is the chromium. Very nice, shiny metal. Manganese is next. We got some little chips of it in there. I'll actually put mineral oil on that one, because manganese does oxidize. There we go. Alright. By the way, I've also got a sample of iron. It's not in my main collection yet, but I did extract some iron powder from hand warmers. They're in these little glass vials here. I wish I could melt them into a solid blob of iron, because it's not very aesthetically attractive, just a powder. But since iron has a high melting point, I might not be able to do that anytime soon. But just to demonstrate that it's iron, let me show you the magnetism. Yeah, it's magnetic. And that was a sphere of magnetite, by the way. Moving on. Cobalt. Arc melted cobalt pellet. Cobalt's also magnetic. See? Nickel. It's a coin. See? In the mouth of the vial. And nickel is also a ferromagnetic element. Moving on. Copper. Nice little nugget of native, naturally occurring copper metal. Copper's kind of a strange element, because it's one of the few elements that sometimes occurs in its pure form in nature. Most elements are never found that way. They're always combined with other elements, and we have to smelt the ores and stuff to get the pure metal. But sometimes copper is found metallic in nature. Oh yeah. This is the sample I have for zinc. I need to get a better sample, but this is the core of an alkaline battery I took out. I tried to melt it, but I couldn't get it hot enough, so it just kind of charred and oxidized. But it does have zinc. It has zinc powder in it. But I need to get a better sample. Admittedly. Next up, gallium. Gallium, oh my god, it is messy stuff. It sticks to everything. Skin, plastic, glass. First of all, I'm going to pour the gallium out and then have it solidify, and then I'm going to break it up and then put it in a vial.